Good morning, everyone. Are you able to hear me? And also see the screen? Can you all please respond to this poll? Are you all able to hear me? Yes or a no? Okay, wonderful. Good morning once again to everyone for joining in the session. Enoch, for the first 5 minutes, can we do the housekeeping work in terms of sharing the YouTube link and in terms of sharing our Facebook and LinkedIn groups, and in terms of it's been more than I think it's the 10th day now, and we haven't done anything as such, and also you will have to give away the awards, right? So
Sure.
here is the link. First I'll just spend 5 minutes, Enoch.
Yeah.
So we have the this is the 10th day, Enoch. I think there has to be some correction done. It's showing as ninth day. So today is the 10th day, and we have all the 10 days of videos uploaded on YouTube. I request you all to just click on subscribe here so that any future video that gets uploaded or any live session which happens, you all are notified. Number one point. Okay. And number two, we are posting the quizzes on social media. Today, I wish to take a slight detour and explain you on what kind of analytics people do on social media so that you all become active in terms of having your accounts. And even before I do that, there is this quiz competition which we are conducting, and everyone who participates, their names will be handpicked. Of course, we give this chance of handpicking to Google, wherein we have a random number generator and it generates randomly a number, and that sequence number, the person who appears there would receive Amazon coupon as a you know appreciation token of appreciation for being active and responding to the questions. So Enoch, why don't you share your screen and run that Google random number generator?
I'll do that.
Yeah, sure.
For yesterday's quiz, we had about, let us see how many. We had close to 204 people who participated in the quiz competition that we had. So we are going to randomly pick one person. So I'm gonna just quickly type in random number generator. And this is a tool by Google, and let's just check. It's serial number 1 till serial number 204. So the moment I click on generate, there will be a number that will pop up here in place of 5. So whatever that number is, the person corresponding to that will be the winner. So without any further delay, let's do this. 3, 2, 1, go. It's number 183. So we have Dr. Kakumani Venkat Subbaya. Dr. Venkat Subbaya, congratulations. You are a winner for today. And we have your details, so we will get in touch with you and we will give you your Amazon gift card.
Congratulations, Mr. Venkata Subaya. Congratulations for participating and winning this. We truly appreciate it.
All right.
Okay.
Over to you, buddy.
Yep. Thank you so much, Enoch. And I think we should now proceed further. But before we proceed further, when you go to our YouTube channel, Of course, I'm doing a bit of marketing here. Okay, so you'll have a LinkedIn page, Facebook page, Instagram page, and the Facebook group. The advantage is that we keep posting interview questions, and we keep posting new articles about the blogs that we are writing. And I'm writing a book, and that book will be affirmatively released on 15th of August. So I request you all to be active, and we are going to give away the ebook for free for a few of y'all who are there on our social media. So I think that's what I'm requesting y'all. So please be active on social media as well. All right, now let's get started. Once again, as usual, we will do a quick recap of all the concepts, and we're going to choose AI and deep learning here. AI and deep learning mind map has been updated. Okay, there are a lot of additional things which we are updating, and the good part is that you'll be observing a lot of things such as subsampling, upsampling. What are the various techniques which are involved in upsampling? What are the various techniques which are involved in downsampling? What are the boundary effects, kernels, so on and so forth? And you all are expected to have a brief read. Okay, you just open this, you just need to double click on each and every branch of this tree mind map, and you will be able to read things pertaining to that. I request you all to do this diligently before coming to the class so that your understanding is much better. And here we go. So people who are there on the Sri Ramam, I'm saying that people who are there on our social media, we will be giving them free ebook. I'm writing a book on data science. Okay, and that book we want to give away for free. The condensed version of it. I mean, quickly, it will be like a novel. You just read it quickly up. Everything is hunky dory. You understand all the concepts on data science. Yeah. So people who are active on social media, they will get a free ebook on 15th of August. We are planning to launch it. Yeah. So please be active. That is an incentive for you all. All right. And already it's gone for printing. A few formalities are going on. Irrespective of the formalities, I'm going to launch it on 15th. Okay, having said that, there are a lot of videos available. Please watch those. Now, without wasting more time, we will get started. I'm going to jump the sessions a bit, and I'm going to show you webcam. Post this webcam, we are then going to go back to our regular trainings. So here there are a few things that I need to show with respect to how to recognize people. So what I'll do is I'm going to import CV2, which is computer vision 2. Then you do CV2 dot video capture of 0. 0 is the webcam. In a few laptops, you will have two webcams. There are a lot of laptops in that way. Stereo laptops will have that, which will also capture the depth. For that case, the video analytics and thermal sensing software or the product that we have built has two cameras. Okay, 0 means you want to refer to the first camera, 1 means the second, 2 is third. You can have as many cameras as possible. So you do that. And then you say that if this video capture is not opened, then throw an error saying that cannot open the webcam. But if the webcam is open, if it's true, then you want to read the frames of video. Video is collection of multiple frames, and we all know about that. Okay, so video is collection of multiple frames of images. Okay, it's collection of multiple frames of images. So you want to capture all these frames and you want to return that. And also we want to resize the frames, and we want to resize it by 50% each. That means, okay, you want to resize, you're not resizing, by the way. And what we are doing is, by using this f of x and f of y as zero point 0.5 and 0.5, we want the video to be centered. And the pixels which are additionally added, we want them to be filled by doing interpolation. That's called as area interpolation. Yesterday we have discussed about interpolation techniques. And then we want to see the image. We want to name the window as input, and then we want to see the frame. And cv2.wait key of 1. We already discussed that if it's 1, then the window that opens will wait for 1 millisecond before you stop it. Only after 1 millisecond you can stop it. I mean, that's immaterial, right? And if c equal to 27, 27 is the ASCII character of the escape key on your keyboard. When you press that, this video capturing will break, and then it's going to release the cap. So let me do this. Let me run it. It's gonna take some time, but you'll be able to see me. Don't do this. Please run. One second. cv2.resize isn't working. If it doesn't work, then I sense this also would not work. Just give me a bit while I try to restart. No, not needed. Let me go to Anaconda and let me open the terminal, and let me once again install OpenCV. This is how you install OpenCV. It says the requirement is already satisfied. Then I am not sure why it is not working. Let me restart the kernel here. Of course, it's tricky. Huh? You have to figure out on what's that issue. I think the latest version has some issue, OpenCV 4.2.0. Okay. And usually I'm also like any other developer, wherein if we get the error, we just go figure out why that error is, arising in the first place. And let me see, there are 13 answers. If there is any of the answer which is going to help us with this. Sorry. Okay, so we are capturing the video. We are returning the, frames. And while true, you want to read that, and then you want to resize that. Height and width and interpolation. If I were to remove these, what will happen is something that we have to look at. Just give me a minute. Uh, uh, it's fine to a great extent. I don't see any issues here. Or would placing it in the brackets help us? No, it is going to throw an error. It clearly says that it's syntax mismatch. Let me see if there is any other better solution available here. Oops, that's a lengthy code. Frame, none. Yep, this is what we have done. Okay. All right. Yep, we are bang on. Really not sure why this is not able to do the trick for us. Let me do one thing. Let me remove this interpolation. Is this a reason? Let us try out. No, that is not the reason. Okay, no problem. I'll try to fix this at a later point in that case. I'm sensing that this also would not work. Oh, this would have been a wonderful exercise for today's session, but that's okay. Tomorrow, any which ways, we will solve it. It happens. Yeah. These kind of things do happen because people, these are open source, and people will be updating the code, you know, very, very frequently. And if they're updating the code so frequently, and if there is any version upgrade or version mismatch, then you keep getting such errors. All I can say is get used to these kind of errors. Okay, the code which I'm going to show now, it might not work after a few days. Okay, just allow me a minute. I'm trying to see if I can do something else to fix that. If I can fix it, well and good. I'm trying to connect a different webcam, and that could be one of the reasons. Yeah, because what happens is in OpenCV, um, or when I connect to this webinar jam, especially, webinar jam is going to make use of this webcam. Yeah. Okay. I'm not sure if I need to enable that to be able to enable this specific version. And let me try that once. Just give me a minute. Um, I'm sorry for this disturbance, but I think I need to remove a few connections and then let me try out. Okay, this time. After switching on the webcam, affirmatively it should solve. I am thinking out aloud on when did I last do this. Okay, let me enable the webcam here. Yep, that's me. If you're able to see me, wonderful. So what I shall do is go here and I'm going to run this. Let me now restart the kernel. I will remove this and I'm going to plug it back again. Let me see what happens now after I restart this kernel. It should work. I'm just trying out just for 2 more minutes. I'll try out. And if nothing works out, we will move on to the next module. Wonderful. It's working. I think that has something to do with the webinar jam, the application, which controls the webcam. Basically, it takes position of your webcam and Yeah, that's me. Good morning, everyone. So, sorry about that. Sorry about this. I'm extremely sorry. I keep getting the calls despite notifying to the people that I'm in training. Sorry about that. So, here we have a lot of, you know, color channels or color spaces. We will discuss more about that. And if I run this, we will get an output. I'll show you that. Let me run it. If I'm going to type a specific digit such as G, okay, let me rerun this part again. It was holding on to the previous module. Let me run it here. Debugging. Too much of debugging. Okay, run this. Yeah. So here, if I type G, it will convert the entire image into black and white image. And if I type Y, this is called as YSP color space. And if I type H, this is called as HSP color space. Okay, these are the various color spaces. That means if I keep moving around, my face is still captured. There are a few other, applications with respect to video. We'll first do that and then proceed further. I'm going to share, this code would anyways be there on your video, which is getting recorded. You can make use of that. I'll spend more time on explaining each of these, just that I want to complete this video analytics portion of it. So this code here is going to help you detect the human face. We'll talk more about this. Yeah, this will help you detect the human face. And the application which is being used, or the algorithm being used, is called as Ha Cascade. And you have a frontal face. Okay, if you have a frontal face, it's going to detect. So let me show you that. Let me run this. There we go. So okay, if I keep moving, it will still try to capture that. That box that is being laid down is called as a bounding box problem. So you keep seeing these applications, right? Like Andhra government has done this application to uh, detect who are the people without helmet, traffic cops. Or you might have heard about a lot of such applications. All those are classic examples of just putting a bounding box. And I can also put a face mask, okay, on the face. I can put a face mask and then we can proceed further. Mask frame is not defined. Okay, that's okay. I'll put that mask and then show you. And then you can also identify the parts of the human body. Okay, for example, say you want to detect the eye of a person. How would you detect the eye of a person? Basically, you first detect the face. Okay, and then it would start detecting the eyes. Okay, this is a typical eye detection model. You can detect nose, you can detect mouth. You can detect various parts of the body. All these are a few things that you can do. Okay. Even if I wear specs, it is going to work. For example, let me wear spectacles. So still it's detecting the eye, right? That's the good part about the algorithm. So even if you wear some specs, etc., it is going to detect you. So these are the kind of applications that can be built with respect to OpenCV. Okay, I'll speak more about these things. Let me connect back my scribbling pad and all that. So just allow me a quick minute to connect the other scribbling pads. Because if I'm done with this video analytics or uh, a few things pertaining to that, then I can connect back my plug and then many things can be done. And there won't be any disturbance henceforth because that was just to show you the webcam part. So let us now proceed further from where we have left. And I'm going to explain you in a very detailed manner about a lot of things. So let me go here and let me show you all the other various applications which are possible. Yesterday we have discussed until this, wherein we have done linear interpolation, cubic interpolation, and we have also done skewed size. Today we will get started from affine transformation onwards. What do we mean by affine transformations, right? And how is it going to help us deal with the images? Okay. Affine transformation is all about doing some transformations to the geometrical shape of the image, right? You make changes to the geometrical shape. For example, say your image is in this format. Say you have an image like this. Okay. This affine transformation says that you need to get hold of 3 points. 3 points of your data. Okay. Now, what you're doing here is you're going with 0, 0, which is your origin. Okay. You assume that this is your origin, 0, 0. Or you assume that this is your origin, 0, 0. It doesn't matter which point you're going to choose as your origin. Okay. So say you choose this as your origin. And then how do you want to transform? This is a source points. You take the first point. Then you say number of columns minus 1, 0. Number of columns minus 1, 0. And then 0, number of rows minus 1. So 3 points are chosen. And then you want the destination points to be different. How different should it be? 0, 0 should be again same 0, 0. And then number of columns minus 1, 0. And here, what are you converting that to? You're saying 60%. Okay, you want to move 60% on this side. and go there. So this point you want it to be the same. This point, second point, you want to move 60% here. And you have a third point, which is this. You want to move that 40% on this side. So somewhere here. This is how you want to change your image to. Okay. So let me explain here that we are importing CV2, which is for computer vision applications. You are importing NumPy, and then you are reading your image. Okay, after reading your image, you're taking your image shape. :2, what would that do? It will go to your image here. It has 3 dimensions. This is 0, this is 1, and this is 2. Okay, you have 3. And then you're saying :2 here. :2 means you want 0, 1, but you don't want this 2. The one which comes at the last in Python, that is ignored. So 0 and 1 would be 256 and 256. So you want to choose those 256 and 256. Once you have the rows and columns, you're playing around with that. You're saying numpy.float32 because you want to convert into a floating point format, decimal format. Okay, because whenever you're multiplying something like 0.6 into something, you'll get values in decimals. Hence, you're converting that to float32 because that will be in decimal format. And then you're choosing 3 points in the source image. So if this is your source image, you're selecting 3 points. And in the destination image, here also you're choosing 3 points, 1, 2, 3. Okay, and what are you doing after that? Let me run it. So you have this. You have source points, you have destination points, and then we are applying affine transformation. Here you are giving source points, comma, destination points. And you're storing that in affine underscore matrix. Then you do cv2 dot warp affine. You have to use this function called as warp affine in order to be able to apply this matrix. So you're taking your input image and you're saying, let me apply this affine matrix, and the destination image should be as big as your source image. So the number of rows and columns that you have as part of your uh, you know as part of your original image, you want the same number of rows and columns to be in your destination image also. So you run it. Then I just do this image show input and output image, see what happens. Look at that. This is your input image and this happens to be your output image. So what has happened if we were to carefully observe that? You have taken the value here and the value here and you have done a mapping similar to this. Then you have taken here and you moved it 60% here. You have taken a value here and you moved it 40% there. This is exactly what is given here. And if you observe the image also got transformed in that way. These are all the kind of transformations which we keep seeing in a few, Photoshop kind of applications. On similar lines, let's take another example of affine transformation. Here, what is it that we are trying to do? We are taking a source image and we are taking a destination image and we are doing certain other transformations such as in the source image, you are taking 0, 0. So we are referring to this point here. Then in the destination, you're making it number of columns minus 1 comma 0. So you're taking it here. Here will be not rows comma columns, it'll be columns comma rows in that way. Row number 0, columns minus 1. I mean, from the last but one column in that way. But why columns minus 1? Because you know what? If you have the various columns, and say you have 10 columns, just as an example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you have 10 columns, okay, if you have 10 columns here, then indexing number starts from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Indexing starts from 0. So this is number of columns minus 1 will give you the last column. Okay, this is the reason why it is mentioned as number of columns minus 1. And then the next in the source, what is the next thing that you're trying to select? Columns minus 1 comma 0, and you're mapping it to the origin in the destination here. So you're taking this and mapping it to the origin here, just like this. And then what are we doing? We are taking 0 comma number of rows minus 1. Number of rows, so again rows start from 0, 1, 2, 3 in that way. If you have 100 rows, then you'll have 99 index numbers because indexing starts from 0. From 0 until 99, so it will be number of rows minus 1, 100 minus 1. Okay, so you're taking number of rows minus 1, so you're going to this point, and then you're saying number of columns minus 1, number of rows minus 1. So columns minus 1 is here, rows minus 1 is here, so you'll get here. And then you're mapping it like this. All I'm saying is you can do any kind of transformation on your image, doesn't matter. It's just that you need to get hold of 3 points in source, and you need to get hold of 3 destination points, and then you'll be done. Okay, so if I just run it, job done. So here is your input and here is your output. What happened here? You hold this, you take it here, then you go to this point and then switch it, then hold this point and then switch it. So you're flipping the image, right? You're in some sense you're trying to flip the image. Remember we discussed about flipping the image. If you're aware of the kind of things that we have discussed, we flip the image. In theory we have discussed about Arnold Schwarzenegger image, and here we are doing this. Then you also have something called as projective transformation, which is the next topic. Within projective transformation, we have a lot of freedom. In order to perform transformations, you have complete access kind of. That means instead of choosing 3 points in the source and 3 points in the destination, here you can choose multiple points. Okay, that will ensure that it gives you a lot of freedom to play around with your source and destination points. For example, look at this. In source you are getting hold of 4 points. In destination also you are trying to get hold of 4 different points, and you do the kind of transformations that you like, doesn't matter. So you're importing CV2 and NumPy. You need not always do it, but whenever you restart your kernel, you have to certainly import your libraries once again. But if you're not doing that, then you need not import each time. It's just there because each is a different piece of code. Then you're reading a file. After you read this image, you are taking the rows and columns of the image. Okay, and then you're getting hold of 4 points in the source, and you are trying to get hold of 4 different points in the destination. And then to apply projective transformation, we need to use something called as get perspective transformation. This is a function which is used when you want to apply projective transformation. Okay, so I can run that. And then you're saying you want to use warp perspective. You want to take the input image, apply this projective matrix on that, and the destination image should have as many columns and rows as your source image. Whatever input image you're giving, output image also should be of same size. Look at that. We are getting hold of how many points? 4 points. 1, 1. Okay. Then you're taking 2 and 2, taking this and this. So you're doing this kind of a mapping. And then you're taking third and this. So you're taking this and you're moving 30% here. So that's how it is. Then you're getting hold of this and then you're moving it 60% away here. A lot of fun filled stuff is what we can do. And how is it going to help? A lot of Photoshop, a lot of interesting softwares that you have wherein artists play with the images. This is exactly what they do. Even in movies, in serials, in media, people use this very extensively. And you can also use this specific function wherein we can have a vertical wave, horizontal wave. I'll run it. And here I'll not do a deep dive into the program, but then I'll show you on what happens. Look at this. You're importing a grayscale image, and then here we have a vertical wave, right? So I have an input image and a vertical wave. Look at that, as if it's dreaming, right? You see these kind of visualizations in movies also. You can do a horizontal wave like this. You can combine the horizontal wave and vertical wave and then do it together. It's called as multi-directional wave. Look at that. You can do all these kind of transformations, which is all about applications of video analytics and image processing. You can come up with a concave shape, right? All this would be there in the video that will be uploaded on YouTube. So I would request you all to make use of that. Look at that concave. Okay. In that way, you can do a lot of analysis. Then remember, we have looked at a lot of filters and I've given you, right, Einstein's image, and then you were expected to do some operations. For example, if it's an identity matrix, you take in this way. So you have Albert Einstein's image that we have taken. We have applied this identity matrix, and then we got a similar image. So here also I'm doing the same thing. I'm taking all these 0 0 1 0 all zeros. This is called as identity filter. And when you have an identity filter, and when you apply that on an image, you get the same image as an output. Also, I'm creating a box filter. If you look at this, we have looked at this also. A filter wherein you'll have all one. And what is the rule of the smoothing filters? This is called as a smoothing filter. It will create blur in your image. It will smoothen the edges and borders, etc. Here, the rule that we have discussed was that if you add all of these numbers, it will become 9. So you have to divide it by 9 so that overall average turns out to be 1. When you add all these numbers, pixel values, you get 1. Then you have kernel 5 by 5, wherein you take 4, 5, and then you take 1, 2, 3, 4, and then 5. And you are filling with all ones, numpy dot ones. You are saying that I want all 1 values here. Okay, and then when you add all these numbers, it turns out to be 25. So you divide it by 25, which gives you 1. Okay, so these are the kind of filters. So you're importing these two libraries, you're reading the file image read, and you're giving the path of the file. And this time we are loading BMP image. I'm just showing you on how you can make use of multiple image formats. Like we have already done it with TIFF. We have imported BMP and so on and so forth. So I'll just import that. And here, whenever you have an image, you know for a fact that it will have rows, columns, and then if it's a color image, you'll have 3. If you look at this, this is the number of rows which has an index number 0. And this is index number 1, which is number of columns. And you have number 2, which has 3. 3 means it is a color image. If you don't have anything over there, that means it is a black and white image or grayscale image. If you have a 0 instead of 3. Okay. So you're saying by doing this :2, you're saying that we should take the first index, index number 0 and index number 1, index number 2 is ignored. Okay, and then you are coming up with an identity matrix. Okay, you're coming up with an identity matrix. And even before that, couple of quick things, it will serve as a recap also. What is convolution? Okay, what is in the first place convolution? Yep. Can you all please respond on the chat window? What do you mean by convolution? Convolution is a fundamental operator in your image processing. Like you have multiplication, addition, division. In that way, we have convolution. What we do is we will take the image and then you take a filter. This filter is another matrix of numbers. Okay, it's matrix of numbers. Kernel or mask or filter. Kernel or mask or filter mean the same. Usually the size of this kernel is smaller than the size of your image. And what we do is, for each of the pixels in the input image, we take a kernel and we place it on top of that. For example, you take this and you place it on top of this, and you do some operation to get the central pixel. So we multiply this with this, plus this with this, plus this, plus this. You multiply all of that, and then you get a number which is going to be your central pixel. Okay. Here, this kernel is also called as image filter. Okay, this is called as image filter or image filtering. The output that you obtain after applying this kernel, so you apply this kernel here and then you get an output. The output that you obtain after applying such a kernel is called as a filtered image. This image is called as filtered. So you're filtering out certain things from this image. Okay. Depending on what values you have in the kernel, it will either detect the edge or it will make your image blur, so on and so forth. Okay. This is one thing. And blurring, when you make your image look blur, that's called as blurring of the image. This refers to averaging the pixel values within a neighborhood. Okay, you take this and you take the average of all these numbers, and what happens when you take an average is it will start allowing only low frequencies. Even if you have a number which is higher here, because of the average it becomes smaller. For example, if I take 10, 30 and 10, this 30 is a very big number in comparison to these two numbers which are 10, right? But when you take an average of these three numbers, what would it become? Or let me take 15 and 15 just for ease of our calculation. So you get total 60 by 3, which is 20. So this big number is getting reduced into a smaller number. So that is what happens when you take an average. So that means only these low values will be passed through, and these kind of high frequencies or high intensity values are blocked. How are you blocking it? By simply taking an average. So I block this 30 by taking average of all these numbers, and then I get 20. So I'm allowing only low intensity values to pass through, hence it's called as low pass filter. Okay, this is called as low pass filter, and it blocks the higher frequencies. And frequencies refer to rate of change in pixel values, simply put, the rate at which pixel values are changing. Okay, and here already I told you that you have okay, here what we are trying to do is we are taking all these identity, and then here we are creating all the ones, and when all the ones are added you get 9. You're dividing it by 9 so that you normalize this. Okay, the bigger the size, more is the smoothing effect. So you can also do 5 by 5. You can increase it to any size whatsoever, and you can see what is going to happen. So I'll do this. Then you're saying show me the original image, and then uh, okay, So here what you're doing is you're saying apply this filter. Filter is two-dimensional. Why is it two-dimensional? Because you're applying this on image. So it's two-dimensional. So you're saying image -1 comma kernel underscore identity. What do you mean by this? -1 is something that you'll understand. Let me run this and then I'll show you and then explain. Yeah, it'll be easier for you to understand. Here also what we are doing is we are taking cv2.filter 2d. Okay, you're taking the image. You're saying -1 comma kernel 3 by 3, which is this matrix. Okay, you want to apply that on the image. Okay, and then you are also doing this, wherein you're saying, let me do cv2 dot filter 2d, and you're saying apply this kernel 5 by 5 kernel and apply it on this particular input image. Okay, and then yep, all right. So this -1 that you're seeing here is actually called as depth. When you say -1, let me erase these things. It's called as depth of image. There are multiple flags which exist, okay? And within this is an argument which stands for depth. So this is how you give. You're saying what is the source image, what is the kernel that you want to apply, and what is the depth of your output image. What is it that you're expecting? Negative number means you want the depth of the source image, whatever is your input image or source image, whatever is the same depth you want to carry forward as part of your destination image also. In layperson terms, if I were to explain you about depth is in the image how close you are or how far you are is going to determine the depth, right? How far away or how close you are, depth, right? So depth is another basically, you know, characteristic of an image. Okay, -1 means whatever depth you have in your source image, you want the same depth in your destination image also. Okay, and then there is also something called as blur directly that's available in your function itself, which is called as cv2.blur. Blur is an inbuilt function within OpenCV. Okay, and you will let your kernel automatically generate some numbers. You're not bothered about that. So let me run all of these at one go, and I'm going to show you all the images that we get. Original image, identity, 3 by 3, 5 by 5. Let's see. Sorry, I'll put everything together. When you take an original image and when you apply an identity filter, you get the same result. And then you have a 3 by 3 filter or a 5 by 5 filter. I'm sure you must be experiencing this now, that when you take your original image and when you apply an identity filter, you'll get the same image. But then if you apply a 3 by 3 filter, there is slight blur in the image. That blur is extremely prominent when you look at original image and 5 by 5, especially in this portion versus this, right? It looks blur. This is the application of blur basically. Also, there is another filter called as motion blur, especially when you have any action movies. Okay, whenever you're dealing with action movies, what happens is your you need these kind of blur pictures, images, as if someone is running very fast. You would have seen the movie Singham, right? In Singham, hero Surya or Ajay Devgan, in whichever version, they'll be running. When they run very fast, there should be that motion that has to be captured, right? So how is that motion captured in this way? So you load your image, you say that you want your kernel size to be 50, you want to fill that 50 with all the zeros, and what you're doing is you're going to fill, it's 15 by 15. Okay, big filter, 15 by 15 kernel. And then what we are going to do here is we are going to fill the central row number of size minus 1 by 2. Size is 15. 15 minus 1 by 2 means it will be 7. So you go to row number 7 and all the columns, whenever you have these square brackets, it's rows, comma, columns. So you're saying go to row, middle row, take all the corresponding columns, blank space or just colon means you want all the columns, and fill those with all ones. Everything, fill it with 1. That's it. If you do this, you'll be doing a motion blur. Okay, and then you take the motion blur divided by the size, and then you apply that filter on the input image. What filter? Motion blur filter. -1 means retain the depth which was there in the source image to your destination, and then you run this. And when you say image show, this will be the name of the window in which you see the image, and this will be the image that you're going to see. Let me run this. There we go. Where is this motion blur? Motion blur. What's the name which we have given? Motion blur. Uh, is it because there are too many windows open there? Could be a possible reason. Yeah, here it is, motion blur. Look at that. It's appearing as if there's a movement. I'll try to compare it with the original image. Now look at this. In comparison to this original image, it's looking as if it's a motion blur. So these kind of things also can be done. We have also discussed about a few more filters called as sharpening filters. If you remember, all those are classic examples of, where did that go, of image processing. Okay, so I'll also show you that here when it comes to sharpening filter, you just apply these numbers. Who gave these numbers? People experimented a lot, okay, with various combination of numbers, and they figured out on what combination actually makes more sense. -1, -1, -1, -1, 9, and -1, and then you have all these. Then you have another filter wherein you have 1, 1, 1, 1 minus 7, 1, 1, 1, 1. And then you have another sharpening filter, which is add all the numbers, divide by 8 and do it. That will also do it. And who is giving all these things, all these filters? I mean, experiment. People have experimented over a period of decades, and then they came up with these numbers. So whenever you apply the filter on an image, you have to do filter of 2D. You take the image, depth is -1, and you apply this kernel. Okay, keep doing that. And then you're saying, show me the image, sharpening. That's the name of the window in which I want to put output 1, this one. Image show, I want the name of the window to be excessive sharpening, and I want this image to be put into that, in that way. So let me run it. What happened? It ran so fast. Did I escape the key? I don't think so. Strange. Okay, let me do one thing. Let me close. Oops, something is stuck. Somewhere it's stuck. Okay, let me try closing it. It's not going to the home window. Yep, now it's fine. I'll just do this one bit of sharpening, and then we will take a break. Yeah, for 10 minutes, and then we'll come back. So this part is what we were discussing. Let me run it, and you'll see that original image. This is the sharpened image. This is the edge enhancement, and this is excessive sharpening. Very, very prominent, you know. You look at that and try to compare it with the original image. Then you'll understand very clearly on what these are doing. So this is sharpened image. This is excessive sharpening. And this is edge enhancement. So the edges can be easily identified. And remember, edges are good features to identify what is there in the image. Okay, so let us take a break for 10 minutes and then we shall be back. Let me write it down here that we are now going to have a break for 10 minutes. It's, I think, 11:37:38. Okay, let's be back by 11:50. Yeah, this should be ideal. Yep, let us be back at 11:50. Hey, hello. Sorry about that. Yeah. Um, Dow races values mentioned. Yeah, the fixed values, do they vary based on the problem? No, they'll be majorly fixed, Deepak. You can change it, however. It's up to you. Okay. Let us proceed further. One second, I think. So, sorry about that. There are a lot of additional things which exist in terms of embossing and all that. So, we will understand embossing. Embossing means it is a filter, basically. Let me zoom it. This is another image filter which will take an image and it is going to convert that input image into an image which is called as embossed image. We are going to take each pixel, okay, each of these pixels, and replace it with a shadow or a highlight. So replace each pixel with a shadow or a highlight. So what we do is we replace a particular region with a white pixel or a dark pixel. If you replace some pixel, a particular region, with a white pixel, then it is going to add a highlight. And if you have a region and if you're going to replace that region with a dark pixel, then you will get a shadow. Okay, yeah, I'll just take an image for example and we shall do this. Okay, so you're taking an image and storing that in an object called image boss input. You can give any name. You can also give your name for the object. Objects can be any name whatsoever. It doesn't matter. And then you're creating certain filters. And what do those filters do? We will understand. What those filters do is you are going to, you know, okay, let me better run this. Okay, so you have all these filters, basically filter values, and these filter values you are by now I'm sure aware on how to write the filter values. 0 minus 1 minus 1, 1 0 minus 1 1 1 0. You can take any of those pixel values or filter values and then apply these filters on your image. So I'm creating 3 such filters. I'm creating 3 such filters. And then you're saying CV2 dot convert the color image to a grayscale image. BGR like blue, green, red to grayscale image. And then you're saying, let me apply a filter, a 2D filter. Here we have a grayscale image. We want the depth to be similar to the source image or the input image. And then you're applying this. Okay, and then um, why are we doing 128? This 128, okay, the reason why we are adding it is because The embossing effect is achieved by offsetting your values, pixel values in the image by 128. So this image of adding 128 will actually create a highlight or a shadow effect. Okay, it will create a shadow effect basically. For that reason, we are adding this 128. Now, if I were to run this entire stuff, you'll get the output and then I will show you that. Okay, look at this. This is the input image. This is embossing north. Then this is the input image that we have. Then we have northwest embossing. And in that way, there are the other images also. Embossing south, southwest, yeah. And then you have an input image. So if you observe this again, I think I have to do it again here, sorry. Input, southwest, and this. Okay, now it will be easier for me to explain you guys. So if you have your input image and northwest, southwest, and you have southeast, how does it work? Let me tell you. Southwest, northwest, whatever be the direction. So you'll have north, south, east, and west. Okay, you have north, south, east, and west. And if you have southwest, then this direction. When I say southeast, then this direction. When I say northwest, then this direction. And look at this northwest. When you're moving from this direction to this, wherever you have edges, those edges will be prominently identified. Okay. And then if you are moving from, say, south, if you are going in southeast direction, southeast, then wherever you have edges in that, you will be able to identify the edges. This is not identifying if you observe. Only southeast is able to identify, northwest is not able to identify. Okay, that's the rate of change along that specific direction. Okay, this is another thing which you can use on your images. And we also discussed about Sobel edge detector. Sobel edge detector, okay, just to help you understand, the smoothing filter that we have done earlier is called as a low pass filter because it will take all the pixel values and take an average, right? If you have pixel values, and I've given you an example that if one pixel is 15, another is 13, 30, another is 15, when you take an average, you get 20. So this is not needed. This is kind of offset. The impact of this is reduced when you average. That is what happens when you use your box filter or Gaussian filter, which is a smoothing filter. But when it comes to edge detection filters, where will you have an edge in the image? If you have an image like this, okay, where will you have an edge? If you're moving in this direction, if all this is white, 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 and suddenly you have a black, then the rate of change will be higher. So edge detection filter can be called as high pass filter. Okay, it can be called as high pass filter. Okay, then we are now going to look at a filter which is called as Sobel filter. And here within OpenCV, you're just reading an image. Okay, and then you're converting that to a grayscale. And then you're saying cv2.sobel. This will automatically apply a Sobel filter. Okay, it will automatically apply a Sobel filter. And then here you're seeing this cv2.cv underscore 64f. This is the depth. Okay, if you have 8-bit input image, you can use 16 here instead of 64. It's just the depth, that's it. You can just do a quick Google search to understand more about this filter or flag. And what is the use of 1? What is the use of 0 over there? I will let you know in a minute. And then if I give you values like this, even before I proceed further, if I were to give you values in this way, wherein I say that you'll have -101, -202, and -101. What edge will this filter identify? What edge will this filter detect? Yep. Please can you answer on the chat window? Please can you all respond to this question? What edge will this filter detect? I request everyone to please respond. I'm sure you all can respond. I'm going to give you a quick 1 more minute. I request everyone to please respond to this. Okay. Vertical, absolutely. Absolutely right. Professors, lecturers, absolutely right. Okay. So you now would be able to guess briefly on what this 1 and 0 means. If I were to give you numbers in this way, wherein I have -1, -2, and -1, 0, 0, 0, 1, 2, 1. What edge will this filter detect? If this is going to detect vertical edge, then what edge will this detect? This will detect horizontal. Okay, this will detect horizontal edge for you. Now, 1 means you want to find the Sobel, you want to apply the filter along x-axis, not on y-axis. Okay, and then if you have 0 here and 1 here, that means you want to apply the gradient or rate of change along y-axis and not along x-axis. Okay, So you have your original image, Sobel along horizontal direction and Sobel along vertical direction. You run it. Come on, Sobel, where are you? Yeah, there we go. I think I need to first close all these images. Okay, let me do that. Let me first close all those images. Yeah, let me close this. Too many images are loaded, so it's causing that problem. So do we have any images now? No. So let me run it once again and you'll be able to see the result. Yep. This is the original image. This is Sobel along vertical and this is Sobel along horizontal. Original image, Sobel horizontal and vertical. Let us understand here on what was happening. So if it is vertical edge, okay, that you're detecting, what happens? You move along vertical direction. Say for example, you're moving from here in this direction. Here, is there any rate of change? No, 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 nowhere, right? So nowhere you have an edge over there. You don't have any edge. But then after it crosses this, here there will be an edge. Yeah, absolutely there is an edge. Okay, even if you move like this, you have an edge here, you have an edge here. Then if you move in this way, you have an edge in that way. And horizontal edge means you move along horizontal direction. And then you'll have an edge here. When you move along, you have another edge here, so on and so forth. But if you move along this direction here on this patch of the image, you won't have any edge. Okay, why? Because it's all the same gray color. So you'll not have any edge per se. So this is how you can apply Sobel and you can look at the edges along X and Y direction. This is Sobel for you guys. And we also have Laplacian. Remember, we spoke about Laplacian filter. If you apply Laplacian filter, the results will be amazing. Let me run it and show you the results. Here is a Laplacian filter. Here is the original image. Look at that. Laplacian has actually given you all the edges. Even if it's a circle, you have a circle there. For this also, you have horizontal edges, vertical edges, circular edges. Circle, remember, what did we speak? Laplacian is very good at identifying the blobs. Blobs are circles. Okay, but it can also identify the other edges. That is the beauty of Laplacian filter. So only if you want to find along horizontal or vertical direction, you can go with Sobel. But if you want to get a holistic view of all the edges put together, you just proceed further with Laplacian filter. It will find the double derivative on both the sides. Okay. And then we have canny edge detector. Okay, that is also something that we have discussed. Okay. So, however, if I just take this plane image, plane, airplane, and then if we apply Laplacian, let's see how it's gonna appear. Here we have the original image. But when you apply Laplacian, look at what has happened. All of a sudden, results are a little weird. Always your Laplacian might not work well. In certain cases, it might work well. In certain other cases, it might not work well. And if you observe all of these things, these are called spurious edges. In Laplace, in images, you might have spurious edges. To counter that, yesterday we have discussed about another, you know, um, edge detection filter, which is called as canny edge detector. Okay, this canny edge detector will reduce the noise, and you have 50 and 240 here, right? What are these two numbers? 50 is a low threshold and 240 is a high threshold value. And you know that if you have low and high, any pixel value which crosses high would obviously be an edge. Anything which doesn't even cross low will not be an edge. And anything which lies in between low and high will be an edge only if it is connected to another edge which crosses high. If it's just like that, no. But if it's connected to this, yeah, it will. So you have canny edge detector. So let me run this and look at canny. Wonderful. And look at Laplacian. Oh my God. Right? Look at the clear difference between original image and canny edge detector versus Laplacian detector. Okay, this is how the difference would be. There are many such things now. You can apply erosion, dilation. Erosion means like the eroding of the things. It will ensure that in your image a few pixels are removed. A few pixels are removed. If you say iterations equal to 1 from your image, the last pixel, outermost layer is removed. Outermost layer. So you take your image, convert them into pixels in this way, and you can remove the outermost pixel. This outermost pixel can be removed. Dilation means you add one layer to the outermost. I can just run it and then show it to you guys. This is the same thing that we are doing. When I say 0, again, I think the images should be just why. Okay, let me get rid of this. Again, the same thing. If too many images are open, then your system would actually act a little weird. So you'll have to restart the kernel and then proceed further once again. This is common. Until and unless you have a very powerful computer. Mhm. By the way, I'm using a GPU machine, but still those problems are arising. So you have an input image, erosion is this, dilation is this. Okay, so very clearly there is a difference of how new pixels are added, how the pixels are removed. Yep, this is one such thing that we can do. And then we are going to get into some amount of fun bit. When I say some amount of fun, we'll be doing vignette. What vignette filter does is it will take your image and it is going to apply a vignette on top of that. I mean, like when you take photos for marriage, right? Say you want to send it to a marriage bureau, or you want to apply on shadi.com or something of that kind. What you do is you go to a photo studio, they'll take a photo, and in this photo, what will the photographer do? They will put this in Adobe Photoshop and ensure that the focus is on this and not on the other portions. Okay, they'll ensure that the focus is on this, not on the other portions. And for this, the within Adobe Photoshop, you'll have something called as vignette. Okay, that's how you pronounce it. So what's happening here is you focus the brightness on a specific portion of the image, and the other portions are faded away. And in order to achieve this, we are going to use Gaussian kernel. Remember what happens with Gaussian kernel? At here, I mean, the central pixel is given more importance, like 4. The pixels which are down the contour, somewhere here, will be given slightly less importance. And the pixels far away would be given even lesser importance. This is what happens. And you are building a mask. Okay, and also the, I mean, since you're also going to control it using sigma. If I say sigma value is equal to say 200, so what will it do? It will take 200 pixels radius and it will brighten that spot along rows and along columns in some sense. Okay, and then once we build this kernel that is along y direction and x direction, you're taking a multiplication of that by transposing, and you're getting a final kernel. So you're applying Gaussian along x-axis, Gaussian along y-axis. Okay, and then you're combining those two. And then we are coming up with a mask. Okay, and we want to superimpose this mask. Okay, I think I'm getting too much into this stuff. It might confuse you guys a bit. Let me run it. I'll explain conceptually what happens. So what is happening here in vignette is it is putting a bright spot here, focus is shifted here, and as and how you move towards the border, the focus is actually getting reduced. It's becoming darker like a shadow. You can also shift the focus. This piece of code will actually shift the focus. So if I were to run this, and if you look at this in comparison to your regular vignette and the original image, look at what's happening here. You're shifting the focus to the top left. In this way, you can create amazing images. Then we have also discussed about histogram equalization technique, which will actually make your image look a lot brighter. In your mobile device, right? Be it Android or be it iPhone or whatever you're using, when you take a photo, and if the photo is not bright, if it is say dark, then automatically your phone will adjust the photo such that it becomes bright. Okay, a photo is dark, but then automatically it becomes bright. So that is what is happening here. So you have image read. You're reading the image in black and white format, and you're applying this equalization, histogram equalization, which is an inbuilt function within OpenCV, and you run it. Once again, we ran into the same problem. Let me close it. It's happening far too much, too many times. It usually doesn't happen that way. Probably it's high time that I restart my machine. Okay, but then let me see if there are any. Okay, memory is so much. All right, Google Chrome is a culprit along with Python. Hmm. All right, now I get it. Okay. So you have this histogram equalization. If I were to run it on an image, look at this input image and equalization. The moment I apply histogram equalization, the beauty here is here supposedly there is some gas. Whenever jet aircrafts fly, you'll see some gas. It leaves behind some gas. Look at that. This gas is very prominent here. If not for your histogram equalization, you would not have seen certain patches as prominently as what we are seeing here. That's the beauty. Even the minute of the details you are able to capture just by doing some amount of slight changes by using histogram equalization. Here also you can apply histogram equalization. It's a different way of applying histogram equalization. I'll just run that and show you. This is in a different color space altogether. You're converting the color of the image to YUV and then you're doing it. I'll run this. And this is the input image, color image, and this is a color histogram equalization in YUV format. It's a world of video analytics and image processing. And here we already discussed about how to access a webcam, right? How do you access a webcam? So using this function video capture, you're saying you want to capture the video, okay? And it will be continuously reading the frames of image from your webcam until you stop. And return here, what's happening is your camera is reading all the frames and then it's placing that in return read function, and then you have frame. Okay. If the frame is captured correctly, it's stored in the variable frame. This loop will keep running until we press escape key. And escape key has an ASCII character 27. So if I type a number or if I type a key, if I press a key, how does the computer understand that I'm pressing a specific key on the keyboard? By looking at ASCII keys. Okay, and cap.release will actually stop the operation and proceed further. And here you are reducing the size of the image by 50%. So you're capturing the frames of images, you're scaling it down by a factor of 2, and then you're doing interpolation, because whenever you reduce the image or change the frame of the image, you want the missing entries to be filled. So this is something that we have already executed and we have seen it. And here you have grayscale, HSV, and YUV. So if you run this and just press any of those keys, such as if you press G, it will convert your video to grayscale. If you press Y, it's going to convert your image to YUV. And if you press H, it is going to convert your image to HSV format. So the moment you capture the image, you can convert it to any format you want it to be in. Okay. And yep, median filter. What does median filter use for? Median filter is used to remove the blur. Okay, remove the blur. So directly you have this median blur. You will take the input image and you're going to apply a kernel size of 7, that is 7 by 7, and you get an output. So if I run this, here is the input image and here is a median filter. In this input image, very clearly, very prominently, we see the outliers. These are all kind of outliers, patches. How do you remove those outliers or patches? Just apply a median filter. This median filter is also called as non-linear filter. And then you get this image. Okay, just to do a quick recap of whatever we have discussed until now. We first discussed about all the basic filters, such as identity filter. Then we discussed about Sobel filter. Then we discussed about Laplacian filter. Then we have also discussed about box filter, Gaussian filter. We have done a lot of different operations. Okay, then we have now tried median filter also. Then we have also, this is all about dealing with images. We've also dealt with videos, wherein we have understood on how to track a human face. Okay, we've also converted the video into all the various color formats, such as you can convert the video to a grayscale format. You can convert that to um, HSV format, YUV format, all these formats. Okay, and we have also detected human eye. Okay, and these are a bunch of things that we have done. We can do many other things, such as there is something called as bilateral filtering. You can apply Gaussian blur. There are many things. You can identify the phase, frontal phase. Here, we'll spend some time. Let me quickly run this because it's any which ways there. And on these images, we are trying to apply. The difference will be very, very subtle. Okay, bilateral filter and Gaussian filter. The difference will be very, very subtle. Okay. This is your bilateral filter and this is your Gaussian filter. Okay, hope you are able to make out the subtle differences. Here in bilateral filter, this image, the edges are quite prominent, but here it's kind of dull, right? So barring that, I do not see any striking difference. This image probably is not the right image to be chosen. Yeah. Then here we have something called as face detection algorithm, right? And this detection algorithm is called as Ha cascade. What happens when it comes to Ha cascades is that people way back in 2001, two people by name Paul Viola and Michael Jones. These are the two people who have come up with Ha cascade. And using these Ha cascades, you can extract features which are called as Ha features. Their objective was to detect the object. And this algorithm is majorly called as Viola-Jones algorithm. What they have done is they have taken an image. Okay, within that image, they placed a bounding box. Okay, and in this bounding box, they calculated A, B, C. They took this A, B, C, D, and they calculated area of this rectangle. And they tried to find on whether the human face was detected in this or not. If the human face wasn't here, they would move this to different regions in the image. They keep moving that throughout the image to figure out at which point people can exactly detect the human face. Okay, and this worked very well because all you need to know is you need to know only the sides. You need not know about everything else. You just need to know about AD, AB, AC, so on and so forth. And using just area of this rectangle, you can detect the human face. And you can do many things. This mask didn't work for us, so let me check whether this is the right location or not in which we have this face mask. Go here and let me type it here. We see a face mask. Oh yes, face mask exists. Not sure why this didn't work out, but let me try once. Okay, I think I need to show my face here. Yeah, look at that mask. Okay, sorry about my room and all that. I request you to just ignore that for now. Yep. So that mask is being overlaid on top of my face. If you see that mask, right? So in that way, mask can be overlaid basically. This didn't work, right? But it's working now. So you can do a lot of animations, animated movies, etc. That you see is being done thanks to all these kind of techniques. And this here, you already have the code written in Ha Cascade, frontal phase, Ha Cascade eye. All these are already available. Then you can have nose, mouth. You can. identify whatever you want to identify basically. And you can, do you know what? Do augmented reality. Augmented reality means on a video, on top of that, you overlay, um, you try to overlay an image on top of a video. That's augmented reality, right? And I will see if I can cover some bit of augmented reality also for you guys. But that's as simple as this. If you know computer vision, all these things that we are discussing, you can do augmented reality and many things beyond that. Okay. So I think it is time to take the second break, and then post that I'm going to explain about a few more interesting things about images. And I think from tomorrow we will get into convolution neural network. Okay, a few practical aspects. So very interesting things will come post the break. So please stay focused. It's approximately 38. So let's join back by 12:50 break time. Okay, so I think we can proceed further. So we will discuss about a concept called as key point detection. Okay. Key points are called as interesting points in an image, basically. What do we mean by that? Key point or interesting point? If I give you an image, you should not be choosing uninteresting points. For example, let me go here. Let me take the seam carving. Seam carving. It should be there somewhere. Not this. Face mark element. Okay, let me check the URL here. Image URL. And yep, here it is. So let me go to this and take the images. Okay, and then the images here. So you have something called a seam carving. This is the image that we will use to help understand the interest points or the key points. Let me write it down here. Key points or interesting points. When you want to downsample this image, that means when you want to reduce the size of the image, okay, one way to reduce the size of the image or to downsample the size of the image is to do away with every alternate row and every alternate column. Okay, delete every alternate row and delete every alternate column. Okay, do this. Just remove every alternate row and every alternate column. By doing this, you might also get rid of a few rows here and a few columns wherever you have ducks. And duck is an interesting point, interesting region. If you're going to get rid of alternate rows and columns here, then you're losing some interesting points as well. How do I ensure that I reduce the size of the image by not touching this duck, because this happens to be the interesting point. Okay, so you are going to find the interesting points right from the start until the end. Okay, by calculating some kind of energy matrix. What does this energy matrix do and how is it calculated, right? So that is what we are going to focus upon now, using this concept called as seam carving. You have seam carving. We will use the seam carving and then try to understand the interesting points. There are various other techniques, friends, to identify the interest points, such as you have something called as sift, you have something called as surf, speeded up robust features, shift invariant feature transform. Okay, and then people came up with something called as fast features from accelerated segment test. Okay, and then you have something called as brief, BRIEF, binary robust independent elementary features, right? And then people came up with ORB, oriented fast rotated brief. So they included these two features, combined them. In this way, there are a bunch of those. Okay, and here all these, and there's also something called as Harris corner detector, which is also another feature which can be extracted from the images. Okay, but then we're going to discuss more on this front. So here, this, 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 I feel that are interesting regions, interesting points. And all these other regions here are uninteresting regions. So you have interested regions and uninteresting regions or uninteresting points. These uninteresting points can be calculated using something called as energy. How do we compute these energy values? Okay, so what we do is basically it's dynamically done by your computer, but we start from the first row, first pixel, and we come all the way until the last row to find the path with the least energy. To find the path with the least energy, we start from the first row and come all the way down to the last row. And we compute and store the best path at each pixel in the table. So what you do is for each pixel, we take three possible pixel locations. So if you want to calculate for this pixel here, then what you do is we calculate the energy of three pixels in the next row. You take the next row and then for the next row, this and this. So one is the bottom pixel, another is the bottom left pixel, and another is the bottom right pixel. So for every pixel, you go to the next row, you go to the next row, and then choose three pixels, bottom pixel, bottom left, and bottom right. And then you keep calculating energy values. When I say energy, rate of change in the pixels. Simple. Energy is nothing but rate of change of pixel intensity values. Simple. And you keep repeating this process until you reach the bottom. Then take the next pixel here. Take that next pixel. Once again, do the same thing. Take one bottom left, bottom and bottom right. Calculate the three energy values. Then go to the next pixel. Okay. Then take that pixel and take the bottom, bottom right and bottom left. And continue doing this process until you reach the bottom pixel. Now what we do is every time we want to reduce the size of the image, we start from the beginning, and if this is the least energy, you go that way. If this is the least energy, again you go that way. If this is the least energy, again you come in that way. So from top to bottom, you keep traversing. You're here, you go in that way, you go in that way, you come in this way, and then you delete only the uninteresting portions and do not find the interesting portions at all, or do not touch the interesting regions or high energy regions. Wherever there's low energy, traverse that path, least energy, delete it. Why do you want to remove every alternate row and column when you have such an amazing technique to solve? Okay, so what I shall do is now, this code would be slightly lengthy. So I request you all to spend some time and read that. Nevertheless, the comments, lines of comments are provided. So I'll run this. Then you're gonna come up with the vertical seam. Okay, now let's see what happens. So look at that. Seams are getting, seam means each line is a seam. from the starting pixel to the ending pixel, whatever direction it takes. Yeah, it came. Wonderful. It came already. Yeah. So let me show you. You have an input image. Okay. And you have an output image and you have the seam carving, which was done. Look at that. So what we are doing is we have an input image. Okay. You're doing a seam carving on that. It's the same size if you see input and output. But then the output image size has reduced. Oh, it's taking only like this or like that. Okay, fine. So much size is reduced. Why? This is all called as seams. These green colors. Look at that. It never touched the duct because that seems to be interesting region. Here also the duct wasn't touched. So all those seams are removed. How many seams did you remove? 20 seams. Like that. Amazing. So you could reduce the size of the image, especially when you are supposed to deal with big images and you feel that you don't have the required compute, RAM that you have or the processor that you have maybe is not sufficient for you to proceed further. So what we do is we just are going to identify the unimportant regions and we are going to get rid of those unimportant regions. That is seam carving for you. Or you can expand the size of the image also. Okay, you can make it big. You can actually remove a portion of the image also. Let me show you that. So if you let me show this. What I'm going to do is with the code that I'm going to show you now, applications are important. Code, of course, overnight you cannot learn that. It would take its own sweet time. And the only way out is practice. Type. You don't copy paste anything. Okay, you type it. So let me run this. It will open an image for me here. So what I can do is I can simply say, okay, all I need is I want to remove this part. I just selected that part, this portion. Okay, I just done that. I've done that. So now what it's doing is for that portion, it is removing all the seams and it will add the seams again. Okay, this portion that I've selected now, I selected only this portion just by doing that. I took the mouse and then I've done that. So it is going to, in some sense, get rid of this and it is going to add new seams. Okay, now it's adding the seams back. Once it is done, it will throw another image at us and we are going to look at that image. Look at this output image. Wonderfully done, isn't it? Now, you do not even feel that there was an image here. Okay, it doesn't even make you feel that there was a chair over there. So very naturally, it removed this portion. Until unless you stress on it, you'll not be able to identify that some portion was there earlier. Beautifully done, right? So the uninteresting parts are removed and the interesting parts are intact, right? So these are the kind of amazing applications that we can do. Ah, And then if you have, so what we have done until now is we uploaded images and we have done a lot of image processing. So we know how to comfortably deal with images now to a great extent. And then we have also looked at how do we real time access the streaming videos. Meaning I opened the webcam and that was a streaming video, right? While I was moving my head on left, right directions, you were still able to, or my system or algorithm was still able to put a bounding box around my face. Now, the third thing that we will look at is what if I have a video which is already available? How do I analyze that? So you just say opens import CV2 numpy and you have cv2.video capture. I'm going to capture the video of birds.mp4 and you'll be able to see the video here. Look at that. That's it. Very simple. So you're doing cv2.video capture, you're giving the video, you're opening the video and you're reading the frames of image and then you're seeing that video stream and it's waiting for 20 seconds before it vanishes. Cool. There is also something called as dense optical flow. Let me, from here on, I'll be a little fast because yeah, we need to complete this portion of dense optical flow. This is all about detecting the objects. So what's happening here is objects are moving, okay, in this direction, and you're able to detect the objects. Even if it is a night view, you can still detect the objects. Okay, let it complete, let the video complete. And this is called as dense optical flow. So what it does is between two different um, frames of images, two consecutive frames of images, it will look at how the images are flowing. What is the direction in which they are flowing? And you have those vectors, those arrows, vectors, which are showing the movement in which the vehicles are moving. There are a lot of other things such as Lucas Canade optical flow technique, right? And many other techniques. These kind of techniques will help you identify the objects even during nights. It's just motion estimation. It just estimates the movement on how the objects are moving typically. It is used in object detection. It is used in object tracking, so on and so forth. Right? There are huge variety of applications which exist, but these are a few examples on how we can actually make use of this. Then we have something called as single shot object detection model. What you do in this single shot object detection model is that we make use of already existing model. People have already built the models. Model net SSD, single shot detection. You're just taking that model. This is called as making use of pre-trained model. In this particular pre-trained model, which was built on Cafe. Cafe is another deep learning library, like we have TensorFlow, Keras, PyTorch, you have another thing called as Cafe. So I'm going to load that. Okay. And then you have various labels. And I should tell you that this training covers only certain aspects. Okay. And our main training will be far, far more detailed and far, far more advanced with a lot of advanced concepts. Right. Those are the things which people need for cracking interviews, kind of. This is just trying to get you all to some level of speed in understanding what is AI and deep learning. Okay. So in your image or within your video, if there are any of these, for example, if there is a bicycle or a car or a bird or a cat or anything of these or a motorbike, etc., it will identify these. Okay, so let me run this part and we will see how it's gonna detect and identify. Run this. Look at that. This is the video that we have, and it is putting a bounding box automatically. Yeah, and as and how your vehicle nears, it gives a probability score on what that vehicle is. Okay, we'll observe this for a while because now after some time there will be a bike, a guy on a motorcycle who's going to come, and we will see on whether our algorithm is going to detect that person or not. Let us see what's happening here. Amazing, isn't it? The algorithms are doing amazing job. Say you have a CCTV footage and real time you can track the number of vehicles moving that way. Okay, and if it comes very close, then the angle of your camera should be such that the number plates also can be detected. But at least this is good enough. Look at that guy who is coming here in the motorbike. Let's see whether this guy would be detected properly or not. Yep, yep. Look at that. It's saying it's a motorbike with 90% probability. Okay. So any of those which I've shown you, any of these, if it appears in your image or in your video rather, it will automatically detect. Okay. There is also something called as scene segmentation. If you give an image as an input, it will automatically segment on which portion, which part of the image is what, kind of, right? So look at that. This is an image that you have, and it is very accurately able to say that, hey, this is a human, this is also a human. Look at that. It has given a different color, different segmentation. Wonderful. And it's saying that this is an object, this is an object, so it could identify this and this. But none of your algorithms would be 100% accurate. So this portion was missed out. This is object segmentation. If I just give an image, it will quickly say that here all we have humans. Okay. In case of riots, okay, in case of night attacking the, say, armed forces, army is going for a war at night times, and they have night vision goggles or night vision, binoculars kind of stuff that they wear. And they need these kind of applications there to be able to quickly segment on what is an object, what is this. At nights, if you're traveling, if you're going in a fighter jet, as such, it's all cloudy. So you should take your best shot. Given the application, applications will help you a lot. We also have a face recognition system which will not just detect you, it will also detect on what kind of emotion you have, whether you're angry or disgust or fear or happy or sad or surprised. You can quickly identify that. Let me show you that portion also. Okay, so let me run this and you'll be able to see that. Would it come here or would it come somewhere else? I think it should come here only. Let's see. Yep. So look at that. It has put a bounding box around the face. This bounding box, which is in green color, it is also detecting that this person is neutral, neither laughing nor crying, kind of, right? Neutral person. We can also determine the age and gender. It's no big deal. We have already done it, and I think showed you on my LinkedIn profile all those things. Okay, so that is why I request please connect on LinkedIn. There are a lot of applications. Look at that. Understand how these things are being implemented in real world. Okay, so all those are practical use cases which we have. And then we also have another application wherein we can detect the humans. You can actually detect the humans. Let me run this. There we go. Come up, my dear algorithm. Is it somewhere here? Yeah, it came up here. Sorry. So frame. Look at this image. Even from the back, it can detect who the people are. It can easily able to detect even from the back on who these people are. It's just putting a bounding box and it's giving a probability. These are a few amazing applications of OpenCV, and there is endless. There are other things also which our team keeps doing, and in order to know more, one way to do is go to InnoDataTix, and you'll get bunch of applications there. And another way to look at it is go to my LinkedIn profile, and you'll find all these amazing use cases. And as and how we have a new use case, we'll be posting these things again and again. Yeah. Just a minute, sorry. Okay. So those are a few things. Yeah, yeah. We have done it, Sandhya. Here. Yeah. Posts and activities. You have posts here. And in these posts, um, one of our own trainer, AI trainer, Shubha, she has done it. Today is her birthday as well. And I'll show you that. Yeah, this has been done by her, basically, this project. Where in real time, when the vehicles are moving in that way, it is going to track. Now you hopefully understand on how. Look at the speed at which vehicles are going. Still, it is quickly able to detect, right? Not just detect, it will also record all of these things in the backend database and automatically count. That's the count. Okay, and if you're wondering on bounding box problem, it can detect your emotions live, and whether you're a male or a female, live it can do it. These are all the projects that we have done. Okay, and yep, if you feel that you might want to watch that once again, but I think there was a guy saying that I'm frequently sharing my profile. Okay, so nevertheless, if you want, you can. Otherwise, that's okay. Okay, I think this should help. Um, Enoch, do you have? Are you there? Do we have you? Enoch? Okay, I think Enoch is not able to hear me, but then here we go. There is this attendance link. I request you all to give the attendance. And if you want to get the access to this recorded videos, here is a YouTube link. Anyways, we will post it on the WhatsApp group, but still, if you want it, you can. Then you cannot detect Anudeep, obviously, right? Whatever humans can do, you can do that. Okay. Yep. Thank you so much for your feedback, and we truly appreciate that. Okay. So I'll just stop the screen share, and thank you all so much once again. Please give your attendance and subscribe to our YouTube channel, and we will take it further. Thank you. Bye for now.